What's going on YouTube? Just helping you out here. And for today's video, I will be doing Chapter 6, Problem 1 in the Fundamentals of Physics 8th edition textbook by Drill Walker, Halliday, and Resnick. And Chapter 6 is Part 2 of Force and Motion. Chapter 5 was Part 1. Chapter 6 is Part 2. And this particular problem talks about a bedroom bureau. And we're given the mass of the bureau. And the question wants to know... Well, part A of the question wants to know what the minimal horizontal force needs to be to get the bureau moving. So the first thing we need to do for part A, I think, is draw a free body diagram. Not everybody needs free body diagrams, but especially for forces, they help me out, and it gives you a way to visualize what's happening, and for a lot of people that's extremely helpful. So let's say this is our bureau. It's just a block, we don't really need it to be anything special, and we'll denote this F of H force of the horizontal, so we'll say horizontal force. We know that the block has a weight, so that'll be mg, and since it has a weight, there's also going to be a normal force up here. And as we know, friction is always in the opposite direction of, well, for a block, always in the opposite direction of motion, so your force of friction will be backwards. And so we need to find the minimal horizontal force to get it moving, which means that when your horizontal force and your friction force are equal, that is when it'll just overcome the friction to start moving. So what we need to do is set F of H equal to the force of friction. And force of friction, we can actually expand that and make that your coefficient of static friction times your normal force. And since we only have two forces in the vertical direction, all we have is force normal and mg, we know that force normal, and we know that since this block is against the floor, it's not floating or anything, your force normal is going to be equal to mg. So this is actually just going to be F of H equals mu s times mg, and we're given mu s as 0.45, and we're given the mass, which is 45 kilograms, and gravity, which we know is 9.81. So when you plug in those values, you should get 198.7 newtons. And then for part B, we are told that some stuff is removed from the bureau in exactly 17 kilograms. So actually we're going to do the exact same thing. So we're still going to have the same equation, mu s mg, but your mass up here is 45 kilograms. And since 17 grams is removed, we have to subtract 17 for here, which is going to be 28 kilograms. Which you're going to plug in right there. 45 right there. But these other two values will remain the same. So when you plug that in, you should get 123.6 newtons. So that's it for this problem. If you found the video helpful, please drop a like. Leave a comment if you have an idea for a future video or a question about something I did. Or you could send me a DM on Instagram, which my Instagram will be in the description below. And please help me out in return by subscribing. I'm just helping you out. See you in the next video.